If three-engine aircraft were so safe, so powerful, and so essential for the most demanding routes in the world, why did they practically disappear? For more than 2 decades, trijets were the symbol of long-haul commercial aviation. Iconic models such as the McDonnell Douglas DC-10, the Lockheed Corporation L-1011 TriStar, and later the MD-11 dominated transoceanic routes, connected continents, and were considered the pinnacle of aeronautical design. At that time, having 3 engines was not a whim, it was a real necessity for an industry that still did not have engines as reliable as those of today, and was seeking the perfect balance between power, safety, and performance. However, today almost none remain in operation. Airlines stopped buying them, replaced them with twin-engine aircraft, and within a matter of years, a design that seemed to be the future became a relic of the past. But this story cannot be understood with a simple answer. They did not disappear because of fashion, nor aesthetics, nor because they turned out to be bad. The reason is much deeper and has to do with how technology, regulations, and flight economics evolved. To understand it, we must first go through that entire evolution, from the birth of the trijet as a necessary solution to its disappearance when aviation took a turn that left it without space. And before getting into that decline, there is a question we must resolve first. What problem so great existed in the aviation of the 60s and 70s that could only be solved by adding a third engine? In that context, commercial aviation was entering a stage of expansion that forced a reconsideration of how long-range aircraft were designed. Routes were expanding, flights over the ocean were becoming increasingly common, and the industry needed solutions that offered a greater margin of safety than simpler designs could provide. This was the technical reality of the time. Twin-engine aircraft simply could not safely undertake the routes that the industry needed to cover. The technology was not there yet, and neither were the regulations. The turbojet and turbofan engines of that generation had very clear limitations. Their thrust was relatively low compared to modern engines, their fuel consumption was high, their service life was limited, and in-flight failures, although not constant, were not rare either. Losing an engine during a long-haul flight was a scenario that was taken into account and for which airlines had to be prepared. In addition, an engine failure during takeoff with an older twin-engine aircraft could be critical because the remaining engine did not always guarantee the necessary thrust to maintain the climb or compensate for the asymmetry. Added to this was another decisive factor because at that time safety regulations required twin-engine aircraft to always remain relatively close to an alternate airport in case of emergency, a limitation that greatly reduced the possible routes. Simply put, they could not cross oceans directly nor fly long stretches where there were no nearby airports, leaving out a large portion of intercontinental routes and making their practical range limited and their performance in the event of an engine loss insufficient for long-haul routes. The classic alternative was 4-engine aircraft, but these airplanes posed a different problem. Having 4 engines guaranteed redundancy, stability, and range, but it also implied high operating costs. They were heavier, consumed more fuel, required more maintenance, and their operation was expensive for many airlines that did not need such a large or costly aircraft for their routes. In that context, a logical question arose for engineers and manufacturers. Was there a middle ground that balanced safety, power, and costs? The answer was the trijet, a configuration that offered exactly what the industry needed at that time: sufficient thrust for long routes, redundancy to compensate for a failure, and a lower operating cost than that of 4-engine aircraft. It was the optimal point between the insufficiency of the twin-engine aircraft of its time and the excess of the 4-engine aircraft. This architecture now made it possible to fly over oceans, comply with safety regulations, offer good cargo and passenger capacity, and at the same time reduce operating costs compared to the 4-engine giants. It was here that the main protagonists of this story entered the scene: the McDonnell Douglas DC-10 and the Lockheed L-1011 TriStar, aircraft specifically designed to fill that gap between capabilities and costs. This need led the market to adopt them quickly, since they solved a real problem for airlines seeking aircraft capable of flying transatlantic and trans-Pacific routes without resorting to the enormous expense of a 4-engine aircraft. Moreover, these models offered an ideal mix of range, power, and efficiency for their time. In fact, for more than a decade, the trijet became the standard for long-haul flights that did not justify a gigantic aircraft like the Boeing 747. The Trijet was therefore born not as an isolated experiment nor as a passing trend, but as the best possible solution to the set of technical, economic and regulatory limitations of the moment. To understand how it came to dominate its era, there is something we must examine more closely, because it was not enough to be a good idea on paper. If the Trijet was the ideal solution of its time, what made it the dominant format of the 70s and 80s? The Trijet was not only born as a necessary solution, it also ended up fitting with almost perfect precision into the real needs of the airlines of its time. During the 70s and 80s, these aircraft ceased to be perceived as an alternative and came to represent a logical way to operate long routes, with a balance between power, range, and operating costs, because 3 engines were not an arbitrary number, but a direct response to what aviation of those years demanded. The first great advantage of the Trijet was power, because 2 engines simply did not provide enough thrust to carry a wide-body aircraft across oceans or transcontinental routes, while 4 engines could do so, but at a much higher operating cost. The Trijet occupied the perfect point between both extremes, enough power to take off with heavy loads, maintain long cruises, and cover demanding routes without incurring the fuel and maintenance costs of a 4-engine aircraft. For many airlines, this difference represented millions in annual savings without sacrificing capacity. Another crucial factor was redundancy. In the 70s, engines were not as reliable as they are today, and an in-flight engine failure remained a possible scenario, so having 3 engines provided an important safety margin. If one failed, the aircraft still had 2 operating engines capable of maintaining stable flight, in addition to avoiding the extreme asymmetry that twin-engine aircraft experienced when losing a wing-mounted engine. For that reason, the Trijet combined safety and control even in emergency situations, something highly valued by airlines and regulators. Along with that redundancy, the position of the central engine also provided interesting advantages. Placing an engine in the tail, whether integrated into the vertical stabilizer or located at the base of the fuselage, offered especially clean airflow that benefited engine performance. This location reduced the ingestion of foreign objects during operations at airports with less well-maintained runways, and also created a quieter cabin for passengers. From an aerodynamic point of view, the central engine could improve the aircraft's balance and, when well integrated, offered remarkable cruise performance. Added to that efficiency was another key advantage: operational versatility, the reason why Trijets dominated the market. As a direct consequence, 3 engines made it possible to take off from airports located at high altitudes or in very hot climates where thinner air reduced performance and older twin-engine aircraft faced greater limitations. They also offered excellent cargo capacity without the need to resort to 4-engine giants, such as the Boeing 747. Airlines could operate long routes, medium routes with high demand, and hybrid segments that required a balance between payload and range. That combination of advantages explains the success of the DC-10 and the L-1011 Tristar, the best proof of their relevance. Both models dominated long-haul international flights and became emblematic aircraft of their era. Later, the McDonnell Douglas MD-11 would attempt to improve the concept even further, seeking a more efficient aircraft with greater range. For more than 2 decades, the Trijet was not an experiment. It was the standard for connecting the world profitably and safely. But the balance of the Trijet would not last forever. Aviation was about to change direction, and that change had nothing to do with fashion or with an isolated decision, but rather with a silent evolution that had been taking shape for years. To understand what came next, there is a key question we must now raise. If Trijets were so efficient and so safe, what happened for twin-engine aircraft to end up surpassing them and bringing their reign to an end? The era of the Trijet did not come to an end because it stopped being safe or efficient, nor because airlines grew tired of it. Its decline began when new ways of understanding in-flight safety and long-range certification started to emerge, changes that gradually expanded what a 2-engine aircraft could do and that, little by little, altered the balance of the market until they opened the door to a profound transformation in commercial aviation. One of the most decisive changes was the emergence of ETOPS, short for Extended Range Twin-Engine Operational Performance Standards, a certification that defines how far a 2-engine aircraft may fly from an alternate airport during flight, and that radically expanded the possible routes for twin-engine aircraft. Before its arrival, regulations required these aircraft to always remain within a relatively short distance of an airport in case of engine failure, which is why for decades they could not freely cross oceans or traverse remote areas. The limitation was not arbitrary. The engines of the time did not have the necessary reliability to guarantee that a twin-engine aircraft could continue a long, diverted flight with only one engine operating. But with advances in engineering and the steady increase in reliability, those restrictions ceased to make sense, and ETOPS emerged to reflect that new technical reality. The key to everything lay in the engines. With the arrival of new generations of turbofans, reliability soared to levels previously unthinkable. In-flight failures became extremely rare, maintenance cycles were extended, inspection intervals grew longer, and efficiency increased spectacularly. Manufacturers such as Boeing and Airbus were able to design twin-engine aircraft capable of matching the performance that previously only a trijet or a four-engine aircraft could offer. With that technological leap, engines were no longer a weak point, but had become a pillar of unquestionable reliability. From that moment on, ETOPS changed the route map of commercial aviation. With certifications such as ETOPS 120 and ETOPS 180, twin-engine aircraft were able to cross the Atlantic on shorter routes, fly over remote areas, and carry out journeys that had previously been prohibited to them. This reduced flight times, shortened distances, and allowed airlines to save fuel and operate much more profitable direct routes. Suddenly, a twin-engine aircraft was no longer a limited airplane. It became a versatile, capable, and tremendously efficient tool. For airlines, it was the beginning of a revolution. In that new scenario, the economic impact was immediate. A trijet required maintaining, repairing, and fueling 3 engines. An ETOPS twin-engine aircraft, only 2. The savings in fuel, spare parts, maintenance cycles, and labor hours were enormous. Moreover, new twin-engine designs such as the Boeing 767, the Boeing 777, and later the Airbus A330 demonstrated a range and fuel efficiency that surpassed that of many trijets. The technical balance that had defined the trijet for decades was broken forever. Twin-engine aircraft could now do the same, but more cheaply. With this new ability of twin-engine aircraft to operate long-haul routes, the trijet lost its reason for being. They ceased to occupy that intermediate position that once balanced power and costs, and instead became an unnecessary and economically unfavorable design. As twin-engine aircraft gained ground, maintaining 3 engines ceased to be profitable, and in the commercial aviation industry, where every liter of fuel, every hour of maintenance, and every minute on the ground count, that economic imbalance ultimately proved decisive. The trijet, which had once been the perfect balance between power and costs, became an unnecessary luxury. The first key point is the most obvious. 3 engines cost more than 2, but it is not just about the additional fuel. An extra engine implied scheduled maintenance, unexpected inspections, spare parts to stock, greater workload for technical teams, and longer ground downtime. Each engine requires specific check cycles, overhauls, and deep inspections, and these processes are extremely costly. For an airline, the 3rd engine was not a marginal element. It represented a considerable increase in cost per cycle. While a twin-engine aircraft carried out its operations with a contained and predictable level of expenditure, a trijet added complexity and expenses that no longer provided proportional benefits. The second point, less obvious to the general public but crucial for airlines, was the complexity of the central engine. This engine, located in the tail, whether integrated into the vertical stabilizer or at the base of the fuselage, required specialized access for maintenance and could not be easily serviced from the ramp. It required specific scaffolding, lifts, additional equipment, and longer intervention times. And its location meant that any repair involved more delicate procedures. That engine, which in its day had been key to giving the trijet the necessary power, ultimately became one of its most costly elements. Compared to twin-engine aircraft with engines mounted under the wing offering direct, quick, and universal access, the tail-mounted engine came to represent a true economic burden. To all this was added a factor that ultimately tipped the balance. Modern twin-engine aircraft were far more efficient. Models such as the Boeing 767, the Boeing 777, and the Airbus A330 not only met ETOPS requirements, but did so with significantly lower fuel consumption. Their large-diameter engines delivered spectacular thrust with an efficiency that Trijets could not match. In addition, having only 2 engines reduced the aircraft's weight, lowered maintenance requirements, and caused daily operating costs to drop sharply. This allowed airlines to optimize fleets, cut expenses, and significantly improve profit margins. In this context, the McDonnell Douglas MD-11, McDonnell Douglas's last attempt to keep the Trijet format alive, arrived too late. Although it promised to be a substantial improvement over the DC-10, the MD-11 did not meet the range or fuel consumption targets that had been announced. In practice, twin-engine aircraft were beginning to surpass the Trijet in efficiency and range. Airlines that had relied on the MD-11 for long-haul routes found themselves with an aircraft that, although capable, could not compete economically with the emerging twin-engine designs. The Trijet, which had been the optimal solution for decades, no longer fit within the new paradigm of aviation. In the end, airlines could no longer economically justify operating an aircraft with 3 engines. Between fuel costs, maintenance complexity, regulatory pressure to reduce emissions, and the emergence of extraordinarily efficient twin-engine aircraft, the Trijet lost its place in the passenger market. What had once been the perfect solution became a disadvantage that was impossible to sustain. But the story of the Trijet did not end there, because when it ceased to make sense in passenger transport, it began to find its place in a very different environment. That opens up a new question worth exploring next. If they were no longer profitable for commercial passenger flights, how did they manage to continue operating for so many more years? Although Trijet ceased to be competitive for passenger flights, they still had one card left to play and did not disappear immediately. During the 90s and much of the 2000s, they found a new niche where they could remain useful: cargo transport. The cargo world had different needs, less sensitive to per-seat fuel consumption and more focused on capacity, aircraft availability, and initial acquisition cost, so for a time Trijets fit surprisingly well into that equation. Unlike passenger transport, cargo does not require comfort, soundproofing, or modern cabin technologies. A freighter can operate at night, use secondary airports, or fly specific routes where absolute efficiency is not as critical as reliability and available volume. Trijets, with their combination of power, wide fuselage, and good range, were particularly well suited to moving large volumes of goods without forcing companies to invest in new and extremely costly aircraft. In addition, cargo operators tend to prioritize the ability to lift heavy loads and operate long routes without worrying as much about optimizing fuel consumption per passenger because there are no passengers. The best example of this second life was the McDonnell Douglas MD-11F, which became one of the most recognizable freighters of its era. Operators such as FedEx, UPS, and Lufthansa Cargo used it for years as a workhorse on intercontinental routes. Its long fuselage, large payload volume, and powerful engines made it especially suitable for taking off fully loaded from hot or high-altitude airports. In addition, the market was full of MD-11s and DC-10s retired from passenger service that could be converted into freighters, greatly reducing acquisition costs compared to a brand-new aircraft. For many cargo companies, a converted Trijet was a profitable investment. It offered a balance between capacity and cost that did not exist in twin-engine aircraft of the time. However, this advantage had its days numbered. Trijets also carried their structural limitations, consumed more fuel, retained the complexity of the tail-mounted engine, and no longer had an abundant supply chain of fresh spare parts. As the models aged, keeping them operational became more expensive. With the progressive reduction in the production of specific parts and components, maintenance costs began to rise significantly. This coincided with the arrival of a new generation of extraordinarily efficient twin-engine freighters, such as the Boeing 777F, the Boeing 767F, and later the Airbus A330F. These aircraft offered similar or greater range while consuming far fewer resources and being cheaper to service. Their modern engines had longer life cycles and required fewer interventions, an advantage that ultimately left Trijets without a real ability to compete against these new models. In that new scenario, gradual retirement was inevitable. From the 2010s onward, companies like FedEx began retiring their McDonnell Douglas MD-11F at an increasingly rapid pace, replacing them with more cost-effective twin-engine aircraft. Other operators followed the same path. Converted McDonnell Douglas DC-10 freighters also began to disappear, not due to a lack of usefulness, but for strictly economic reasons. Operating 3 engines, especially one located in the tail, ultimately became unsustainable compared to ultra-modern models designed for a globalized and highly competitive cargo market. Today, very few Trijets remain in active service. Most have been retired, stored, or scrapped. Some continue flying with very specific operators, generally on infrequent missions or in countries where fleet renewal progresses more slowly. Looking at that almost silent present, it is easier to understand why Trijets, despite being practically absent from the skies, still hold a very special place in aviation history. Their current residual presence is not a symbol of failure, but the natural consequence of a sector that evolves relentlessly. Today they fly only in the hands of niche operators, but their impact is deep. And it is precisely now, at the conclusion of this analysis, that we can fully understand why they emerged, why they dominated, and why they ultimately fell behind. Trijets were born as a direct response to a technological limitation. The engines of the time were not powerful or reliable enough to entrust long routes to a twin-engine aircraft. For years, they were the ideal solution, combining power, safety, and versatility. They connected continents, enabled new routes, and offered airlines a perfect balance between range and cost. Then came ETOPS, accompanied by a new generation of turbofan engines with extraordinary reliability. Suddenly, twin-engine aircraft could do what had once been unthinkable: cross oceans efficiently and safely. From that moment on, economic logic prevailed. Maintaining 3 engines no longer made sense. Fuel consumption was higher, maintenance more expensive, and the competition from modern twin-engine aircraft was simply unbeatable. Trijets were retired from passenger transport, found a second life in the cargo world, and eventually were replaced there as well. But their disappearance does not erase their importance. Trijets represent the transition between 2 eras: the era in which engine reliability imposed strict limits, and the modern era, where engineering allowed twin-engine aircraft to become the backbone of global air transport. Without Trijets, the evolution toward long-range twin-engine aircraft would have been much slower. Their role as a technological bridge was essential. They introduced aerodynamic concepts, structural solutions, and operational practices that continue to influence the design of modern aircraft today. Understanding their history also changes the way we view aviation. When we see an MD-11 in a museum, a photograph of the L-1011, or a DC-10 preserved in an exhibition, we no longer see just a 3-engine aircraft. We see a brilliant solution to a problem that defined an era. We see a design philosophy that allowed aviation to grow and expand before technology made a new balance possible. Trijets are a reminder that each stage of aviation responds to its context, its technology, and its needs, and that nothing remains the same once innovation enters the scene. Today, their legacy lives on in modern twin-engine aircraft that soar through the skies with efficiency unimaginable decades ago. Aviation continues to advance, and every design tells a part of that story. If you enjoyed this analysis and want to keep exploring how the machines that transform the world really work, subscribe and join us in the next videos. Here, the journey continues.